Let me try. Why it doesn't give me option to select a window? Okay. So hello everyone and welcome to today's session. So today we will cover this code lab. It's advanced Android in Kotlin 5.3, and I will share the link in chat. So before actually starting with the code lab, so if you are already following the previous sessions, you can see that you have already familiarity with the existing code labs. If you see here, 5.1 testing basics. Second one is the dependency injection and testables. And now we are at this point gonna continue with this testing coroutines and Jetpack integrations. Okay, so just I will close my video for the moment. Okay. So in this code lab, we will test a couple of things related to the Android application in general. We will see how we're gonna test the coroutines, how we can test the room database, and how we can test the data bindings. Most of you might not familiar with the data binding, but we will see according to time. We can directly switch to end-to-end testing if we don't get that much time to testing the data bindings. So what you should already know that I already discussed, we need to be familiar with the 5.1 and 5.2. You know the basic concepts of what is view model, live data, data binding, and navigation component. And you have the application architecture that we are going to start today, like working on the code base. The sample code is following the guide to app architecture, which is provided by Google and Android fundamentals code labs. So all the links are in the code lab. So if you want, feel free to check those. And then you also know the concept of coroutines, like how they work and what is view model scope and how we can scope our coroutines or any kind of process or task to the view model scope. So quickly, I can share a little bit about view model scope. It's basically it's kind of scoping some process or some task to the view model. So that until your view model is active, you don't need to be worried about clearing the services or canceling any API calls. Whenever your view model scope is get destroyed or cleared, all the relevant stuff related to that view model scope will also get cleared. So in this code lab, we will see run blocking. You might have heard of this one already. Run blocking we can also use in production code sometimes, but it's not like the recommended approach. And then there is a specific version for testing, which is run blocking test. And we will see what are the differences and why we should consider run blocking test over run blocking. Then there is a test coroutine dispatcher, then how we can pause the dispatcher and how we can resume the dispatcher. Because if you see the coroutines, they are basically synchronous behavior. We don't know like at what time we're going to expect the output or the function gonna return us a result. For example, if you are calling any API service in your application. And then we will see how we're gonna use the in-memory database builder, which is if you are familiar with the room database, like if your application is having a room database and you need to test that part of your application, you can use the in-memory database builder for that. So what you will do, these are the couple of things. We will modify the code base, whatever the provided by the developer team, and then we will see how we're gonna add the test, how we're gonna use run blocking test, and pause, resume dispatchers, and coroutine dispatchers, test coroutine dispatchers. So the first step is the app review, app overview. So this is the app. It's a note-taking app. So either you can download the zip from this link, or you can clone this repository and then check out the code lab too. But for a easy peasy way, you just download the zip from here and then just open it in Android Studio. So so you already opened the code. Let me know if you want me to increase the font size or if it's okay. I will continue with that. But in the meantime, I will just run the application to actually see how this app is working.
It would be helpful if we can increase the font size a bit.
Okay, I will do that. So this is basically the application. It has it is using the navigation component to switch between multiple fragments. So this is the main fragment. This is the statics fragments. This is the navigation drawer. And when you switch to task list, there are two menu options. You can filter the task list here. So, and then there is a menu where you can say clear the completed and refresh the list. And then there is another one for adding new tasks. So if you want to add something, and then see here, it will just call the refresh and show the snack bar. And you can edit the link, or if you can mark it as a done, and then just filter the list. So this is how actually basically app behaves. So this is what you basically gonna do with the code lab, like the application, how application works. This is I just explained like overflow menu and what are the options are there. And this is basically the app architecture, which is basically the recommended for the moment by the team, Android team. So we have a task activity, task fragments, then there is a view model, then there is a repository, one for, and then we have a data source. One is local data source and the remote. So remote is responsible for loading data from network, and local is responsible for handling room, which is like a wrapper over a SQLite. So it helps as a developers providing a better way to like you don't need to write complex queries or creating everything by your hand. It provides a lot of concise way to actually access the local database. And then I just explained it uses the navigation component, then it has different screens and layouts in XML. So this is basically the structure of the project. So if you see here, this is the structure of your project. It has a folder for each component, like add or edit task, then data, which is having source, like local, remote that I just explained. Then it has task data source interface, repository, and then default task repository, and then it has a result. It's kind of a wrapper over a result, like to providing a different states of to the UI based on the result, if it's success, error, or you are loading data. And then task class for representing the object of task. And then we have statics, then task details, and then task activity adapter, because this is by it's a recycler view, I guess. So that's why we have adapter here. And then we have task view model. And you will see we have a multiple, like each component has its own view models here. And then in the application, so just a little bit text, I will explain it here. So they extend the application, and they what they're basically doing is here, like actually they're using the library called Timber. It's basically for logging your events, and it's more helpful than like I never use it too much, but I found it really useful, because when you want to log something, you don't need to provide a create a tag by yourself. It will automatically refer the class name as a tag, and then you can throw your message into the whatever method you want to log, like if you want to log errors or verbose or debug, whatever. So they just this line is doing is like whenever the build config is debugged, so if you are in build variant, you can select there are two options, debug or release. So they are making sure like if the mode of the build is in debug, then plant the debug tree for logging. And then they have a service locator. This is basically because in this lab we are not using dependency injection like a hilt or a dagger or coin, but here they are basically using the service locator to provide different objects or dependencies to view models or wherever they want. So in this case, if you see, it provides task repository, then create repository. These are the creation of all these components is private, if you see here, and then they are just using these component like methods to get the dependencies. And this visible for testing annotation is to just to expose this function for testing purpose out of its current scope. And I think we will see where it's used. And this is the run blocking, which is actually we can use in production code too, but it's not recommended because run blocking means you are blocking your current thread. So if you are working in Android application, that means you are most of the time you are on the main thread, which is like your rendering happens most of the time. UI interactions and all that things are on main thread. So whenever you try to achieve something like a synchronized, make sure you are doing right that it doesn't froze the UI or your application. Okay. And you can check the nav graph. It like there are like this is the fragments there, like the connections. So the third step is introduction to review of testing coroutines. So what coroutines are, like as I told, it's basically how our program behaves or executes. So either synchronized, like you have 10 core lines of code and there each line executes in step-by-step order, like one first line, second or three, something like that. And here, if you see this diagram, it explains pretty well, like how actually what's the difference between synchronized and asynchronized. So in synchronized, it basically executes the program as it's written or as it's like if there are three functions, for example, we have three tasks A, B, C. As you are trying to achieve those tasks, you follow that order and you cannot switch back and forth. So A, B, then C. But in synchronous behavior, it's basically like there is a behavior which can be synchronized. So there is no any kind of no dependencies. But if there are dependencies, that you might need to like follow the synchronized pattern. But otherwise, you have a freedom of doing something which is not actually required at the moment. But you start like the processing of something, and you know that you need that result later on. And coroutines, with the help of view models, observers, help us to actually achieve that kind of functionality. So we just throw the task A, B, and C all together, and there might be A or C synchronous, and then the B task here is basically asynchronous. So what that means is like we tell to the that's our strategy. Like we started something in task B, but that the output of that function or process is not available right away. So whenever it's available, we use some sort of combination of view models and live data to actually get the updates from that process. So as I just mentioned, it's a synchronous code. Basically, it's a non-deterministic behavior. Like you don't know when that gonna be happen. So you might see like whenever you want to test these kind of functions or programs, every time you run, you end up with a different output. Like output might be the same, but there is a behavior different. Like you don't know the actual behavior. Like if you are expecting that this function will take like for example 3 seconds, but you are not sure, like maybe in the first time it just you get the result in less than 3, and then next time it might take more than that. So here that's what they actually trying to say, like if A will finish first and B sometimes B, so they both are not dependent, and we are doing the synchronously, so we don't know like which one going to be finished at what point of time. So how we're gonna test these kind of behaviors. So in production or like in actual code, we have a synchronous code, but when we try to test these kind of functions or this kind of um, programs for like for the testing purpose, we need to like somehow like create a behavior or actually the environment where actually everything gonna be behave like in synchronized way. So whenever we run A, B, or C, we know that actually what we are going to expecting from that function, and the behavior is like whatever is that function is doing, it will be behave like as a synchronized, but actually it is synchronous. So this is basically synchronization test thread. So you see like every time whatever we are doing, it's basically operations. It has asynchronous operations, but when we have asserting the results or expecting to verify the outputs, we know that every time we will end up at the same point. It doesn't matter if all those components are asynchronous or synchronous. So next, so we will see like in the coming steps, they explained like what to use, what not to. So there is a run blocking test, which is basically a specifically recommended for run blocking test. And then there is a test coroutine dispatcher for local test. We will see why we need that one. So step one is observe how to run the basic coroutines in test. So this is, if you downloaded the code, don't update any dependencies because it might create some kind of issues. So I will just keep that as it is when I downloaded the project. So you need to add your app's build.gradle file. I actually opened the solution code here. Another one. So it's in the app module. If you see in this build file, so there is a Coroutines version for Android test implementation. So this is basically the dependency required if you want to test Coroutines in your applications. And when we add Android in front of, like when we use this version of adding dependencies, that means we try to expose or we want to use these dependencies with our Android tests, like the instrumentation tests. And when we just want to test like for example unit tests, in case for example for a view models or any other things that are not interacting with the Android framework at all, you can just use the test implementation of that same library. So here if you see, we have Android test implementation and then we have test implementation for coroutines. So as I told you, like this is a recommended to use run blocking test, and why they actually want us to use the run blocking test is should be here. So run blocking test, what it does is it skips the delay functions. If you see here, it skips any calls to the delay, and it executes or runs the code immediately, whatever is that coroutines contains. So delay is basically it's basically, if you are familiar with Java, we have thread.sleep. So this is basically the sleep version of it's a version of basically a thread.sleep version in Kotlin. So you can call delays in your function. So if you have any function that has a delay in there and you want to test that and you are using the run blocking test, it will skip all those calls and run immediately all the code. And it also provides another features like we can resume and pause or dispatch or coroutines at some specific time and to test the behavior. So we will see this test. So it's a task detail fragment test. So they are talking about, take a look at this example display in GUI. So they are talking about this example here. So here what we do is like we create the model for a task, like we create an item called active task. Then we call the repository.save task. So if you see here, this little icon, like a pause or play pause icon in like a music one, so that means like it's showing like this function is a suspend function. That is like you cannot call like out of any other coroutine. You can only call suspend functions within any coroutines, and run blocking test is basically providing that scope. So if you see here, it basically providing us a test coroutine scope to test this function, this behavior. So when we wrap all the implementation here with the run blocking test, every statement from here onwards, from line 1, will execute in a order and synchronized behavior. So although this function is suspend function, let me, so you see, this is the suspend function, but it will behave as like not a suspend function, like it will finish, then the next steps will be executed, like then the line number 68, then like moving forward, and then it will test all the things. So if I click on that and we'll run this, so this is recommended, like whenever you are testing any code which like you want to, like there is a suspend functions that are going to be called when you try to test your application, then you need to make sure that you're wrapping them with run blocking test to actually expire. Then you can only able to make sure that you are actually achieving the same expected behavior every time you run your test. And it's really helpful when you have integrating this, your test run on every build. For example, whenever you make new build for your application and your CI/CD pipelines also run these tests, then it will be like a very helpful. Otherwise, you might end up with a flaky test that sometimes pass or sometimes fails just because of suspend functions in there. So you see one test pass. So this is because just because of run blocking test. If I'm using run blocking, it will still pass. But the thing is like there are features provided by this that are we are not using in this case, but there are other functions or other test components that we will see later. So experimental coroutines API, because this is not finalized, because this is still in the experimental stage, and this is whenever you use the coroutines test, just make sure you will get the lint warnings, and you can simply add this annotation to your at class level or your function level. As I explained to you, because run blocking test, it is used in above code because we are calling this function from repository, which is save task, and it's a suspend function. And it provides the synchronization mechanism. So as we discussed earlier, like it will skip the delay calls and run everything in a synchronized way. So we have like expected behavior, what we are expecting from a test case. So the next step too here is observing the run blocking in test doubles. So this is the another major difference. Run blocking is not a part of Coroutine's test library. So this is actually available in Kotlin standard library. So that's another major difference between these two versions of run blocking. So we will open the fake repository and see the so which one is that observed task? Okay. Observed task here. So if you see here, we are using the run blocking version, not the run blocking test. And you can use that one, but again, if you need that, otherwise you can simply use the run blocking. But most of the time in test, they recommended that. And here is the major difference that you can see, like as I told, it skips the delay calls and it gives you the time control. This is the main feature like run blocking test provides. It's the like you can control actually at some point you might want to resume or pause your coroutines dispatchers to actually see some, like you might have assertions in between your tests, like not every time you're gonna test at the end, like assert this value is equal to the expected result from that function. So if you have that kind of testing behavior that you need to test in between some assertions, like when we call the refresh, there might be a loading. So we want to make sure that the loading value is true at very first step. And then when the refresh task is done, then the loading value is false. So those kind of behaviors cannot be tested with the help of unblocking test using those features like time control over the coroutines. And why fake test repository is using the run blocking? Because we are not actually testing here something. If you see here, this is the fake implementation. So when you are testing something, you would prefer run blocking test. But here, if you see this repository is used somewhere, like whenever we call the repositories, if you see the here, so this repository is this one. And here, if you see, we are creating the fake Android test repository. And then here we have run blockings. So this is basically that we provided the implementation for testing purpose. Like we provided the fake implementation of a repository to the Android components. So that's why this is basically kind of a same. It's basically you can say like it's a production code, but just you only gonna use in your test cases, not like actual code. So that's why we are using run blocking in the fake Android test repository and run blocking test when we actually test something. So to quickly get the idea like when to use this one, whenever you have any function annotated with test and you want to behave that as a synchronized, you can use the run blocking test. And like in all tests, you should prefer run blocking test. And for other cases, you can use the run blocking to provide the synchronous behavior to your test components. Okay. So that's basically how we can test the coroutines with the synchronized behavior. This is the step 2. And so we covered the step 3 introduction to the testing. What is next? So coroutines and view models. So if you have familiarity with coroutines, like all the coroutines, they requires a scope. So that scope helps us to tie that coroutines to some scope, like to, for example, view models or activities or fragments. And that helps us to cancel the coroutines at some point if we want. And most of the time we don't want to cancel them manually. So when you coroutines to any scope, and whenever that scope gets invalidated, your all the coroutines also gonna be like a stop or cleared. For example, if you tie your coroutines to activity, whenever your activity get destroyed, the coroutines will automatically get cancelled, whatever is active there. And same for fragments and view models. And if you want to use the KTX versions, like the Android KTX library, they provide a couple of extension functions that you can use. For example, view model scope.launch and view lifecycle owner.lifecycle.scope, something like that in fragments or activities. As they mentioned here, to avoid these, like you don't want to create a manually coroutine scope. Like if you have 10 coroutines and you are using like in multiple places, then you need to provide scope manually. But to remove, like to avoid this kind of boilerplate code, you can use the lifecycle KTX, which provide this function for a view model so that you can tie your coroutines to the view model scope. And whenever the on cleared is called, the scope is cancelled and everything is gonna be as you can get also cancelled if it's coroutines or whatever is like attached to this scope. And the another main thing, whenever you have view model, you are using the view model scope, the by default dispatcher, it's the main dispatcher. So by main here, we mean is like the main thread. So whatever you are doing is not going to be automatically switched to any other thread. So if you're doing heavy kind of calculation and you think like when you type say like view model scope.launch and you're doing something, you need to be careful to actually managing the dispatchers by yourself, because by default view model scope is having dispatchers.main and it uses the Android's looper.getMain looper, which provides the access to the main thread. So you need to be very careful when you try to do some kind of heavy tasks or API calls to make sure you are not using, like you are not doing something which is taking a lot of resources on the main thread. Otherwise, you might face ANRs or any kind of frozen screens, and like a very it will be like a lot of penalties in terms of performance of your application. So but you can see like there are libraries like retrofit and some other libraries that sports, like even the room sports the coroutines, so they will automatically handles the dispatchers and thread switching for you. So another issue when you want to test your view model and you are using the view model scope.launch and something happening in there, then you in the testing you don't have access to this thing like looper.getMainLooper, because this is provided by the Android's framework. So for testing your view models, we need to somehow provide our dispatchers that are going to replace the dispatchers, like the main dispatcher, with the kind of dispatcher that is not from Android framework. So that's the point where the test coroutine dispatcher comes into the scene. It provides us the dispatcher for testing view models, and it basically helps us to set the main dispatcher for a test. So we will see how we're gonna do that. So task view model test. So we go here. Okay. So right now we didn't set up the dispatcher. So if I try to run this, I hope it will fail. Let's see if it fails or, but no. So I think I already have that code which is working. So let me check if I have, oh, I think I added the rule here. Yeah, this comes later into the scene. So if you see now, our test is failing, and we will see why it's failing. And if you see the error, it might not be that much visible, but it says like modules with the main dispatcher had failed to initialize. For testing, dispatchers dot set main from can be used. So it provides a exact information like why this test is failing and how we can fix it. So that's what they are explaining here. So when I run that test, it fails, and why it fails? Because it tries to load that dispatches.main, which is provided by looper.getMainLooper, and we don't have access to that in our test cases. Then we can use the test coroutines dispatcher actually to provide the main dispatcher for our testing purpose. So we covered this one. So our test is failing for because we don't provide the main dispatcher here. So as I just explained, the error is basically this. The error message tells you to set main from that, like from the coroutine test. So replace dispatches.main with, so this is the step actually we need to do. Like we need to replace the dispatches.main with test coroutine dispatcher. So we need to add, there are 3 steps to replace the main dispatcher. So we will first add the test dispatcher, and then we need to add some coding after and before methods. I will explain why that needs. So this is required. So we need to have the test dispatcher. We initialize that here. Then we're gonna set the dispatches dot set main. So the when we annotate the function with before, that means like it will run before every test. So before every test actually starts its execution, it will set the dispatches to the test dispatcher, and it will basically setting the main dispatchers for our application, for our component that we want to test. And this is basically the function here. After means like after every test. And what we are doing here is like we reset the dispatcher and then clean up any coroutines that are attached to that dispatcher. So if I run the same test, like again, it will pass because we are setting the test dispatcher. You see, all the tests 3 of 3 will pass because we now have provided the exact right dispatcher for testing, which is provided from the Coroutines test library. So the next step is, it's basically really important one. So for example, right now we are like playing with the code lab that is a very little, like I can say just a 2 or 3 unit tests for view models, right? But in actually when you are at job or when you are working for some big companies, there might be 100 of classes that you need to test, and they, if they all have coroutines, and then you need to write every time before and after method and make sure you reset the dispatchers, you set the main dispatcher. It's really annoying in those cases. So how we can actually avoid that kind of code, even it also leads to the code duplication in every test, right? So how we can do that? in this in this step, they provide us a like a way to create a rule. So what is rule? Basically, we in unit testing in the J unit, we when we provide the rules, that helps like it will kind of it will attach certain conditions and if to the your test. And when we here we have the main coroutine rule. So if you see here in the code, we set the dispatch, it has a dispatcher which is called by default we set it to the test coroutine dispatcher. And then we have when we override the test, it's basically a test voucher. And when we implement that, there are two functions. So this starting and finish, you can say like they will be behave like after and before methods. So every time start will run, every time before will after will run after the end of the test. So what we do is like whenever we start a test, we make sure that dispatchers dot set main to the dispatcher, which is we defined a default to the test coroutines dispatcher. And then in the end, we are doing the same thing that we are doing in the after method. But now if we have multiple classes, we don't need to add after and like in the after section or the before section these lines again and again, like dispatches dot set main, then reset the main, and then clean up the coroutines. So this is basically just the explanation that I just told you. Like it's extended, which implements the test rule interface. And these methods, they match whatever we have written in the before and after, and it implements the scope. So we will see how we can use this. So use your, this is basically where we have just defined the JUnit rule. So how we can actually in, integrate that rule in our lab, in our test. So before that rule, we need this much code, like these number of chunks of piece of code in every test, every class, like every view model or whatever test is there. So that will be replaced with just basically 1 or 2 lines. So if I go here, I think, yeah, I already have here. So now we don't need the test dispatcher here because we already provided the default. So we don't need to call the dispatches.set main. And we don't need to reset here because that rule is providing us all of this functionality under the hood to us. So now our tests are still passing, but now with the lot of we don't need a lot of boilerplate code here. So this is how actually we can use the test rules, like JUnit rules, to avoid the duplications, and it helps us to write more concise code even in case of tests. And we just finished that one. It runs as expected. And the next step is like using the main coroutine rule for repository testing. So if you have done the previous code lab, you might be familiar with about dependency injections, but because that helps us to replace the production version of classes. So, but here we don't have that dependency injection. So if you see the default, we have fake repository implementation. So we are using that version of repo. So wherever we need dependencies, we provide the fake dependencies. So here, if you see our default task repository, it requires basically 3 things, but you can, like, we have dispatchers already as a default value, but for task data source, we have remote and we have local data source. So we need to provide the implementation, or you can provide the modes, but it again, it depends how you want to test or how deep you want to go with your test. So we will see how we can use the main coroutines. So the above code injects a local and remote as well as this. Because the dispatcher is injected, you can use this. So what they actually want us to do is, like, they don't want us to hardcode this dispatcher, although because we have set this, we can override it, right? Because we just set the default value. So if we don't want to provide any dispatcher, it will use the dispatchers.io. But in case of testing, it helps us to provide the dispatchers, any other dispatcher if we want to. So we will go to the default repository testing class. So I will open that. So they want us to add that rule in this class. So I will copy this code. Yep. So we have main coroutine role. Okay. So as they have this to do, they want us to replace that. So I think here we can say main coroutine role dot. Let's make sure I'm doing it the right way. So use this instead of unconfined when defining your repository and the test, similar to this, executes task anyway, but it doesn't include all of the testing benefits. So this is basically available in, it's not from the testing library. So if you want to, like, as I explained earlier, there are more features in the testing. So they basically want us to replace the here, not with the dispatcher of the main coroutine, but it's fine if you want to do that. But they actually want us to set it to dispatchers dot. Even this is not from the testing, but because we provided the rule here, main coroutine rule, so whenever it tries to access the main dispatcher, this will be provided by the main coroutine rule, and that is from the testing. You see here in the above code, remember that it swaps the dispatcher dot main for a test coroutine dispatcher. So this is the major important thing here is, like, whenever we are calling the unblocking test, it creates a new test coroutine dispatcher. So if we are not defining, or we are not specifying one, if you have 5 tests, and you have using the unblocking test, they all create their own test coroutines dispatchers. But main coroutine rule that we just added, it also includes its dispatcher. So if you see the main coroutine rule here, you see it also has it's a dispatcher here. So what we can do is, like, rather than directly calling the unblocking test in our tests, we can use that main coroutine rule. And what it do is, like, now every time if you have more tests in your case, like, I think here we have only one test. So if you have multiple tests, rather, because that's going to be a costly process if we create test coroutine dispatcher every time. So you can use that rule everywhere, wherever you want to test your stuff in your tests. So instead just using of run blocking test, call the run blocking test on your main coroutine role, and it will make sure that we are using the same dispatcher for all the tests. This is basically just what we have did here. And if you run here, everything's supposed to be working. So let's make sure. Yeah, so we have one test and it passes. We have run blocking task because the repository, this function is a get tasks is a suspend function, and we're just making sure that its data is equal remote tasks, and remote tasks we have defined here. It has this. So this is basically how we can use the test coroutine dispatcher to swap the main dispatcher in our Android in our test. And another thing is like it helps us to reduce the cost of creating test dispatchers every time we are using run blocking test with the help of writing coroutines rule. And you can basically, if you have your projects, you can simply grab this main coroutine rule and dump it into your test project in folder, and then use that in your tests, and then just write your test and make sure you just extend the, like you call run blocking test on that rule, not just directly using that. So this is the main feature of why like why Android team, or why we are actually prefer to use the test coroutines dispatcher, like run blocking test instead of run blocking in our test cases. Just a sec. Okay. So if you want to control the execution of your coroutine, then in the case of testing, we have access. We have a freedom of pausing the dispatchers or resuming them at any point in during the testing, and these are the functions. They are available from test coroutine dispatcher. So we will see how we can use. I think that's they want us to do in this code step. So what they want us to do is like they want us to open the statics view model, and they want us to change this with this. Okay, so they want us to state view model. Oh, it's a statics, I guess. Yeah. So this is currently basically whatever we get from the code lab. So what they want us to do is like, so now if you want to test this view model as it is really challenging because it's accessing the application, and the application comes from the Android framework. So you need to actually write a code which also have access to Android framework. So whenever you have your want to test your view models, you should consider using the view model rather than the Android view model if you don't want to integrate Android framework components with your view models. So we will just take this out. We will remove this, and we will provide a, okay. So now this is basically in the constructor, we will provide the repository, like the object of repository to our view model. So in this case, we can provide any implementation. So in a production code, you will provide the actual implementation. In other cases, you can provide the fake implementation of your repository. So in this way, we can easily test our view model. Okay, so now we have that. At the bottom of this view model field, that takes a plain task repository. So what they want us to do here is we will copy that. They want us to update the view model factory, which provides the object of view model when we try to access those inner fragments. So where they want us to have that fail outside the class. Okay, so outside the class, so we need to add the view model factory. So what it does is like this function, this factory, it will take the repository as a object, and it will provide us the view model for our class for our fragments. So now if we go to the statics fragment, okay, so where we are initializing our view model. Okay, so here So now we need to update the view model because it now taking the repository as a parameter. So you can use the, it's gonna be the same, but rather than just closing the brackets here, it needs the factory that we have just created in our view model class. So now all good. So this is the factory that we have just added. So we give the repository to that factory and it generates the view model for us. Okay, so we are good, and I think the next step will be the testing. So they want us to create this test. I think I have it already here somewhere. Okay, no. So when you hit the option enter on your class, I'm using Mac, so it's option enter. I'm not sure what's in the Windows. So there is an option called create test. So JUnit 3 or 4, I guess 4, let's do with that. Destination package. We will, if you want to set up before and after, and there are a couple of methods. So I will not add everything, but you can, if you want to test everything, you can just check them all. But for the moment, it should be in Android. It should not be in Android test. It should be under the test because this is going to be a unit test. So now we have our test here. And now they want us to do like add the instant task executor role. This will swap the background executor used by components to for an executor which will execute task, and this ensures that's a deterministic. So we need to add the instant task executor roles because we have the live data and we are doing a lot of stuff synchronously. To provide the synchronous behavior, we need to add this rule in our test. If you already see the existing view model test, we already have that rule. Then we need to add the main coroutine rule, then create a fields for view model and test doubles for, if you're familiar with the doubles and mocks, you can see, you will see how like you can provide the dependencies to our view model. So I will just create this. I will just take the code from there and just dump it here, just to easy, little bit easy for us. So once you grab the code, it will automatically imports for everything. But if there is something missing, you just hit option enter and you will see the options that you can import. So we added the main coroutine rule. We added the instant task executor rule. Now we have, this is the subject under test, which is our statics view model. This is the fake repository, which we are going to use in this case for testing. And this is like this extends the task repository, implements the task repository. Okay, so this is the way, like if you are not using the dependency injection, you can provide the, like in that case you don't need to like provide manually, but you can just inject these things. But here we need to do the like manually inject that like a create object. So we initialize the repository, and you see here the difference. We are providing the actually a fake implementation of a real repository, and now whatever functions are using like a static view model is calling on this repository will be referring to the functions that are implemented or existing in this fake repository. Okay, so now we will do the test for loading indicator. So here what we do is like, as you know, when we refresh the task, if you see in the app, I guess we have app running here somewhere. Okay, so okay, this is the application. So you see this loading icon here. So it loads the tasks for us. So they want actually us to test that behavior. And this is not the UI behavior actually we are testing. We are testing the values for that loading. So this is the field in the data loading. It's existing in the, it's in the static view model, and we want to test the refresh function. So I will grab the function test for that, and I will explain you how that works. Okay, so getter of weight. And these are all the dependencies are there for, and you need to import the Hemcrest core matchers. The dependencies are over there. You just need to make sure that imports are resolved to the appropriate ones. So what we are doing is here, like we call the refresh function on statics view model, and if you see here, it sets the value to true, then it launches the suspend. This is the suspend function, and this is the value after loading the refresh task for us. But if we run this test right away now, it will fail because of synchronous behavior of our refresh function in statics view model. So you see here why it fails, because we call the refresh and then we immediately wants to test both the values at same time. So we are assuming that at this point this value should be true, and the next moment it should be false. But actually it is something, if you see actual implementation of this function, it is basically first it's true, then refresh the task, then it's false. So how are we gonna actually fix this? So this is the say like copy, we just dump the code, import the Hemcrest, and doesn't really make sense because it's testing both true and false that I just explained at the same time. And because we are using the test coroutine dispatcher, so our functions basically finished actually before hitting the last assertion. So it fails at the first assertion that we have like a true for our data loading. So how are we gonna fix that? Let's check. So this is basically how we want to do. So when we setting the value, that's I just explained, like we need to check here, like actually the data loading value is true. And once we have done with the refresh task, we have the false, and then we have to check here. But why they added the comments here, because they are just explaining us where we actually need to test the value of the loading indicator. So there it comes to the scene, like because if you see, we are not asserting everything at the end of our test. If you see here in the test, we are not testing now everything at the end. Like we first call this, now we will test true. We need to pose the our dispatcher when we call the refresh, and then after that we need to resume our dispatcher, and then we verify the value is false. So we will see how we're gonna do that. So as you see here, they want to pause the execution, then make sure that the loading value at that point when we pause the dispatcher is true, and then after that, once this done, we make sure that our dispatcher is like our value is that. So this is the final code for that one. So let me just take that code here. So now what they do is, like on the rule, we just call the pose dispatcher and we call the refresh method. And if you see here, at that point, now our dispatcher is posed at this point. So we can test that value, because at this point, this is true because refresh is, that's what the actually value when we call the refresh method. So at this point, this is here. So we have true here. And then execute the pending actions. So then after asserting that true, now we resume the dispatcher and it will execute the refresh functions, other components like refreshing the tasks and setting the value to false. And then you can test the value to the false. And if we run this again, it will pass. You see, now the test is passed because of now we are posing the dispatcher at right time. And at that point, the value is set to the true for the data loading indicator. So these are the basically just two major functions. Like you can pause the dispatcher, you can resume the dispatcher, but there are other functions like advance the time. You can advance the time. You can there are a couple of other options that you can check the documentation online and use accordingly, whichever is like suitable for your test case or required. Okay, so the next one is like testing error handling. So most of the time so far, if you see the test cases, we have only added we have tested the happy path. Happy path means like everything goes smooth, like we loaded the data, we have data, and we are testing everything is as expected. But there might be a certain cases when you want to, for example, you want to load data from root database and you are expecting a list of elements, but if there is nothing exists, then that means there you want to show error, like there is no data available, or if there is something went wrong, you throw some kind of exceptions. So how we can test those kind of scenarios? In this case, we in this step we will see that how we can actually implement the unhappy path of our code. So basically, how are we gonna deal with that? We need to add some kind of Boolean flags into our fake repository implementation to that. So if you see here, they added the should return error to the by default set it to the false, and it's in fake test repository. Let me check if that code is actually there. Okay, fake test repository. So it looks like it's not there. So let me add that. So they want us to open the fake repository, then they want us to add the should return boolean here, and then create a set return function. And what this function basically does is like it just update the value of should return error. So basically here we manually tell to the basically using this flag to return or like modify the returns of our functions based on that value. So we will see how actually we're going to use that. So they said like wrap the get task and task in if statements. So if this is true, the method result error. So we have these two functions. Avoid import conflicts. Okay. So they want us to override these, like replace these two with that. And I will just make sure that the imports are correct. Okay. So now you see here, like whenever we try to get the task, like when we call the get task, the result might be a error, right? You never know. So if we have the flag set to true, we will throw the error. Otherwise, we return the task, or at the end is again error. But our function more probably will end here or here. So it will never basically reach here. Same for the get task, like when we want to reserve a list of tasks, we use same thing here. We added the flag, and so now they want us to add a test for returned error. So statics view model, it has that. Okay. So this is basically the code for the error states and empty states for the tasks. Like then we get the results and we see if there is any error or if it's the success case. So they want us to test here. They want us to test the error state here, this one. So what they want us to do is like to take this code in statics view model test. I think it should be open somewhere here, statics view model test. Okay. So now you see here, we call the set return before actually calling anything and before actually testing anything. So it says like load statics when tasks are unavailable, call error to display. Okay. So now if you see, we are actually testing the error states of the functions of the view model. So we set the error and then we call the refresh method on here. It calls the refresh task, which is here. And if you see the implementation of the fake Android repository, it's not that one, it's this one. So it actually end up here on the error cases in both the functions, whichever is called from the view model, and based on that we will test the error case or the empty case. So let's run this test and see if it passes or fail. Okay, test. Okay, so we just run this test. So when we call the statics view model dot refresh, we have task repository dot refresh task. Okay, let's see the implementation. So this is the implementation in the fake repository. So what it basically do is like it just update the value of the observable task here, and it calls to the get task. And get task is basically this one. If it's error that we just called here. So we set the error, we call the refresh, it calls the repository, and the repository call the get tasks, and based on that we have these two values that are expected to be true based on that. Let me just close this. So just have a fake Android test. We can close that for the moment. So this is basically get tasks is called get called when we call the repository, and this is like refresh tasks, refresh tasks, refresh tasks. This is the method which is called when we hit the refresh, and it calls to a get task, and that returns the mess. Like it expects the result to be mutable live data of result of type, which is containing the list. But in our case, we don't have, because we set the error, so we don't have data. So this is how you can test the error cases by adding some sort of Boolean flag that you can set and return the data based on that flag. Okay. So yeah, this is how you can test the error cases. And the next step is step number 7, which is testing room. So this is important if you have a room database integrated in your application. I think here we have that one in our application and app inspection, I guess. Let me run the application. I think that should be somewhere here. Yeah, so this is another important feature of Android IDE. So if you have a local database, you can have an inspector, like you go to the app inspection, then there are a couple of inspectors. So you select the, by default, this is the selected one, which is database inspector, and you can check the databases for your application. So we have task table, we have the master table. So basically we are here. So right now we have 2 entries. So you can basically play with this. And if you see here, okay, I marked the other one as a done. Oh, live updates. Okay, so you see the values updated 1 to set to be completed. I think we can, if we can change that. And it's updated. So you can actually see the live updates to the database also. So this is one of the really cool features of IDE itself. But we gonna do the testing. So they want us to add the architecture component testing library to your instrumented test using this. So they want us to add the core testing library. So let me check if it's not there. Okay, so yeah, if you downloaded the code, it's already there. I think it should be, but they want, I guess, for Android. Now we need it for Android ones because we want to test the room database. So let's add that dependency here. And you need to sync your project. Let's it sync and create the tasks, tau test class, create this class. Okay, so let me check if it's there already or not. So this is Android test. We have data.source. So they want under local and then create task DAO test. Okay. So here, if you go into that data.source under the Android test package, they want us to create a new package. They want us to call it local. And they want us to create a task class. You can just copy, and this is really also cool feature. You just, wherever you want to dump that code, just go over that package and hit command V, and it will import and fix everything for you. We need to import it. I guess this one. Yeah. Okay, so we have that test class created for a task DAO. We have added the instant task executor rule. So execute each task synchronously using the architecture components like live data or some other components. So we have added the 3 annotations, experimental coroutines that we already saw in the other tests. Run with Android JUnit 4. This is the base class for running the Android X tests. And the small test, there are 3 different versions like medium test and large test. You can read more about, like you can do it by yourself. So let's see how we're gonna do the testing of our database. So we want to add a layout init to database. And then we want to add the before. Let me quickly add the code first, and then I will explain you guys how we can test our databases. So here we are, like this is the method, basically the before, like before we run a test, any test, it will initialize the database. So when we are, if you see in the first, I guess first step, we explained why we are going to use this in memory database builder. So this provides the the dummy database where you can perform the testing for your application, for your database of your application, in our case which is to do database. So this is just for testing purpose, not like the real database for your application. And whenever you do the testing, you make sure like in after you just close the connection to your database, which is here. So we have just done this, we have initialized our database. So this is the main feature, why we need to use in memory, because we don't want to store this information in our application. So once your test is done and the process is killed for your testing, all the data is gone and there is no any data information is saved for your database, whichever is you are like in simple terms, you can say like the interactions from here doesn't impact your database at all. Okay, so they want us to do task for insert. They here want us to insert task and get by ID. So there they want us to make sure that when we try to perform insertion operation in our databases, that operation happens successfully. And then how we can verify that, we insert and then we load the data from the database, and we will check like if that task is already existing in our database or not. So let's import this. Okay, this is impressed. Yep, and get task by ID. So yeah, you just make sure that you import this like is not null value all from impressed, and these are from JUnit. And yep, so let's see how what we are doing here. So because we are testing, so we are using run blocking test here, and then we are inserting, we created the task object, we access the DAO, and DAO is basically data accessible object for our database. And we have insert task function on here. If you go there, you see here, it take the task and insert into the database, and we can define the policy, like if there is already existing one, just replace that. So we insert the database. So when get the task by ID. So now we have already insert. Now we need to make sure that is existing. So we call the get task by ID. This task we have created, we give the ID. And this is the case here, like where entry ID is equal to task ID. So if we run this task, it should work. Yep. So our test is passed. So that means like whenever we are inserting it, have like it works as expected, and then we are accessing that task and it behaves as expected, and insertion is successful. Here we actually tested the two cases for our database. Like first is insertion, and then second is accessing the data from our database. Okay. So yeah, if you see for your to making your life easier, they provided all the imports that are required for this test. So next thing, this I will skip this. So you can next test the update function of your database. So if already task is there, so if you see before here in the, I guess, so this is basically the update to the existing task. So whenever you do any changes to your data here, it will, in the background, it just triggers the modification, like the update to your database. So you will need to do this by yourself, and there are three to dos, like insert a task, update the task, and then the accessing that and make sure that the updates are there. So this is you're gonna do by yourself. Okay. So step 6 is creating an integration test for task local data source. Okay, you just create a test for DAO. Next, you will create integration test. Okay, so they want us to test our local data source. So let's see, where is that? I think we don't have the test there yet. So let's see the class first. So they want us to test this class now. So what this do is like it takes the DAO, it takes the dispatcher, which is now here by default to the IO. What it do is like it takes the result. If you see here, we give it the access to the database. So whatever result it gets from the database, it maps it to the results in form of result. If it's a success, it maps, if you see here, it maps to the success. Here same success, and these are the functions that are not yet implemented, and same here. So it's basically a kind of, you can say, wrapper over accessing the database. Like you should like have if you want to manipulate the data return from your database, you can create a task local data, like any kind of, for in this case this is task local data, but it can be any data, any name for your class. So let's create a test for this. We call that, and this should go under Android test because it's interacting with Android components, for example room database. So we'll create that test, and here it is. Okay, so I will take that just for again copy pasting. Okay, everything resolved. This is from this. Okay, so instant task executor rule is again required because of we need a synchronized behavior. And now this has medium test, and you can read about those annotations by yourself. So they want us to add these two here because our local data source needs a DAO, and to access that DAO, we need a database. And That's why we added here a database property. So we will see later how we're gonna use that. So now they want us to do this, like create a before function. Then we need to create a database, because otherwise we are not able to access the data access object of our database. So this is basically what we are doing here. We are using the in-memory database again because we want to test, and then we pass that database, and then we pass the dispatcher as a main because we want everything to be behave synchronized in our tests. Okay. Oops. I just missed the method entire. And you need the after function just to make sure that you close the resources, things like databases and all that. So we create the database. We have now the data source ready. Now we will see what they want us to test. So they want to test save task and retrieve. So this is basically going to be an interaction with the DAO. Like first we insert the task, and then we get the task, and we will see if the result is as expected or not. Let's take that code. Okay, run blocking. So here they are using the run blocking, but you should always prefer run blocking test. So here we created the new task. Then on the local data source, we call the save task. And if you see, it calls the insert task on our database access object. And when then we will retrieve the task, and then we assert that the result is what we are expecting from our database. So let's run this test. So our test is passing. So yeah, it's behaving fast. Let's test if there is any specific, if there is any kind of failure or not. I should expect it should to be passed. Oh, so there is a has not job completed yet. Yeah, so because here we are not adding the main coroutine rule that is going to help us with the dispatchers, because that will provide us the, if you remember the from the previous test, we have the rule, and using that rule we get the dispatches for the run blocking test. So that's why they are using the version here which is run blocking. So if you want to use a run blocking test, make sure you are using the rule for the main coroutine rule here also, you by including this one, and then using run blocking test with that. So this is just the explanation of this test that I have just that we have just covered. It's basically a success case. So next here they want to like to you guys to do another one by yourself, which is like writing test complete task and retrieve task complete. So what you want to do is like you need to first you need to save the task. Basically this is the step I will explain and you will implement later on by yourself. First create any task, insert that, then update the existing task. Maybe you can set its status to the completed. That will trigger the update to the database, and then you will check the retrieve. Then you will retrieve that task from database and see if that is matching with your updates or not. So this is basically three use cases going to be covered by this case. So first one is like insertion, then second is updation, and the last one is like retrieving the information. Okay, so I will skip this one. This is basically related to the data bindings. So if you are familiar with the data bindings, like we have how we can use the data bindings for probably I guess two-way data binding, like when you can bind the data from your view models or your data objects to the XML files. So how are you going to test those kind of things? So for these things, they want for the espresso test, you need to turn off your animations. And this is they explained here, like how you can turn off the animations, and then you can write the task for your activities. And you can do this by yourself. And I will move to the final one, which is end-to-end navigation testing of our application. Okay. So by here, I guess the data binding, they by here they by the data binding they means like actually setting the data to the UI, not the data binding that I explained earlier. Sorry about that. I guess that was what I understand by the data binding. But here they are talking about like verifying information is matching to the UI components. So you see here, save the task to the repository, then you launch the task activities and click on the task on the list and verify that all the data is correct. So this is what actually you're gonna test is, so you save the tasks in the UI, you see here, and when you tap on any of the data, you will actually test these things, like the information about the task is actually available to the UI. So this is gonna be a pretty easy. It's not the data binding that I was thought of. So I think it will be easy for you. Okay, so next one is the end-to-end. So when we are, it's basically a navigation test. So we are making sure like when you tap on the any task, you are going to the task details activity. When you tap on the back button of your device, you go back to the previous page or previous fragment or activity in your application. So this is basically like how you just want to make sure that the navigation behavior of your application is also going to be tested, not just the unit tests or activity tests are there, but you will make sure that navigation is also works as expected. So if you see here, it's we have a couple of components, which we are navigation drawer, we have toolbar, we have up button, back button. So let me show you the quickly. So this is the up button here. This is the back button. This is the device back button. And then you have the drawer. So you will test, they want to test the components like navigation. So when we hit on here, we land here. When we hit statistics, we have land here. And when we are here, we hit back button, we make sure that it just kills the app or just, or I guess here to make sure that we go back to the list of tasks. Same for the back button. So when you are here, you land here. So they want to test these kind of behaviors of our application. Okay, let's go to Android Studio. Okay. So they want us to create the app navigation test in Android test folder. So which is here, not here, not here, directly under the main package. So we will create a new, I guess, Kotlin class. Okay, so add the appropriate annotations. So I will copy this code because they are expected that we have completed the previous step for importing the proper resources. So let's, so yeah, this is another dependency that is needed for uh, for data binding idling resources, because data binding now here they are talking about the data binding, which is I'm talking about previously, which is like when you want to tie your data from directly with the XMLs from your view models or your other data objects. So we need to add the dependency for idling resources, which is done in here. Okay, turn off animations. Yeah, you see here, they want us to add this implementation for Espresso. I hope it should be there, but somehow it looks like not. I think it should be Android test implementation, if I'm correct. It should be from Android test, but let's just follow the and see if it works. It's still no resolving, so it should be Android test implementation. No, because we need it to be implementation because we are actually adding this to our production code. So I guess we might. Espresso version is there. Why it's not still resolving? Let's check. So they said in your application code. Okay, so let's check where they actually talking about idling resources. So we'll wait. Okay, you can use the idling resource synchronization, idling resources. So we have added this, also add these options. Yeah, these are the two options that requires for testing when you want to integrate the idling resources in your application. But this is still not resolving somehow. So let's try. So this is goes into your Android component. So it should be here somewhere. So we are, or you can just take this because we already have this value here. So we will just take the second one and you can comment this. Okay. So where we are now. Data binding, I think they created another class for, they might have created a custom class. So let's see if they did something. Create an idling resource in under utils. Let's create first this class. So they want us to create one class in utils. So we will add that. Okay. It allow you to implement a decrement, create an example. Here's an example of how would you use this. So you can simplify this by creating this file in the file. So the another thing they want us to do is this. So there is currently issue Espresso does not work well with coroutines. So they added the issue here. Okay, use this in default repository. Yeah, it's here. So we need to write the data binding idling resource. So this is the class they have written here. Okay, let's take that class. So it should be in utils, and we have here. Okay, fragment. Okay, we're good. Fragment scenario, dot on fragment. Okay, so we are getting error at the last method. I think we might miss something. So it says sets a fragment for a scenario to be used for data binding scenario. This dot activity equals to that. Okay. Okay, let's see if we are using any. Okay, so this is somehow, I think, referring to the return issue. So let's require nothing found here. So I think it's some messing up with this. It's not about the return. This is about something here. No, that's not the solution. So what they are doing here is let's for the moment import that. And let's go to here and see if we can able to run this. Okay, so we have this class defined. I will skip that error step. But if you follow the step 8, it will land to the final step version of your step 9. So they want us to copy these 3 test cases there. And we'll take those tests. Okay. So we are using the monitor activity. So I will comment this function for the moment because I guess we are not using it in the navigation. So I will comment that out for the moment. And let's see if this test is working. So we will see how this works. So basically they want us to do these tests. Like these are the tests basically from the step 8, but here you just, they all will pass because we are not asserting anything. We are not actually doing anything with the cases. So again, this is basically step 8 or 9. I will leave on you guys to implement the test for this. And if you feel stuck at any point, you can check the solution code in number 10, but I would highly recommend you guys to do this because this is going to be very similar with the UI testing of task activities. So click on the list item, then edit, then they just define the steps, and then you just follow these steps. And this is basically the same as a step number 8. And if you feel anywhere stuck, feel free to check the solution code, but try it by yourself first. And that's pretty much for this code lab. So if you want to see the solution code and want to get basic idea, you can directly grab from step number 10. And from here onwards, what we have covered in this code lab, what is the run blocking test coroutine dispatchers, view how we can use the test coroutine dispatcher to swap the dispatcher of view model scope. What's the difference between run blocking test and run blocking test? And this is the last 2 steps, like idling resources with the data binding that you're going to do. And we test the data layer, which is like room database access object. Then we have test the local data source. Then how we can simulate the behavior of errors in a case of if there is any kind of errors, how are we going to do test those things in a test. So this is basically a couple of things that we have covered. I would suggest you guys to like take time and go through this code lab again, and if you find any issues, feel free to ping us on Twitter or LinkedIn. And here are a couple of references that they provided for to understand in depth what is navigation components, work managers. There are a couple of sample projects, official testing, sample, espresso, sunflower demo. This is very good sample application. So feel free to check that. And the last is like, this is where you can also continue with another advanced code labs related similar to these kind of labs that we have just did. So yeah, that's pretty much from my side. Thank you, everyone. So let me stop sharing my screen.
Thank you. Such a great session.
Yeah, so if you have any questions, feel free to ping me on LinkedIn or Twitter. This is my handle. So yeah, it was pretty lengthy, I can say. It's a new like a lot of new concepts. So I hope you guys have a little bit understanding how these things work. So yeah, Sagar, thanks.
Yeah, thanks, Nav. That was a great session. Just curious about your experience writing test cases in general. So today's session was really great. We learned a lot about how to write test cases and everything. So I'm curious about what you have to say, like on the job being an Android developer. We tend to write a lot of methods, having a lot of like lines of code. Maybe we have like three different methods having 50 lines each. And let's say we are making multiple network calls within one method. So, what would be your suggestion how to break up test cases? And ideally, what should be the right number of test cases in order to ensure that our functionality is working fine? What are some of your insights for that?
Yeah. So the first thing is I can say like before actually starting that, like if you have a multiple calls, like if you have multiple asynchronous methods in your single function from view model, try to separate them if you can, because that will easily help you to write a more robust test, because then you have less dependencies or less uh, asynchronous stuff going on in a single method. And if you are able to do that, then you can simply follow the testing strategies according to that one, right? Because then you have separate methods and you can write tests for each of those cases. But if you have if you still have multiple scenario, like a multiple calls, like you need to do, like you don't have any other options. Like sometimes we need to have those kind of scenarios, right? We need to call multiple APIs and then process accordingly. So in those cases, the option is like just run blocking, because it will make sure that everything is like running in that case. And then for the test cases, I think it most of the time we might don't have QAs in our, and especially in mobile teams, we don't have quality engineers like that are specifically writing tests for us, right? Then like it's mostly the developers, like we see the specs and we get the help from the BU or the like, business analysts to figure out like what are the possible scenarios. And then I guess from there onwards, you try to make sure that you cover as much as test case, like the scenarios with your test cases.
Got it. Makes sense. That was helpful. Thanks.
Yeah.
All right. Do we have any other questions from the attendees? Okay. So, yeah, thanks, Nav, for joining us tonight. And a reminder for all the attendees that we have a Boston Android Slack channel. In case you have any burning questions which you would like to hit us up, so just send us a message on Slack. You can reach out to Nav, me, Beth, or Jen. We would love to help you out. And so the next session, let me see. Yeah, so we take a 1 week break. So ideally, there's no session on April 21st, but we do return on April 20th, and that session would be all about Jetpack Compose. So stay tuned for that. With that being said, let's wrap up for tonight. Thank you for joining
Thank
us.
you. Have
Thank
a nice
you.
evening. Bye.
Bye.
Thank you so much.